Good morning, everyone. Now, today we are going to learn on distance time and speed time. Okay. Now, before we learn on distance time and speed time graph, I need to introduce to you these three concepts, which is very important before we start. First is speed. Now, speed refers to how fast, a person travel. Second is distance travel. This is how much or how far a person has traveled. And lastly is the acceleration. Acceleration means how fast the speed is increasing. Okay, I'm going to mention about what is the A, distance time graph, and B, speed time graph. For distance time graph, we read off the distance from the y-axis, and we find the speed from the gradient of the line or the gradient at the required point. For speed time graph, we are going to find the distance traveled. It is the area under the graph, and we read off the speed from the y-axis, and lastly the acceleration we find from the gradient of the line or the gradient of the tangent. This will be illustrated later. Now let's look at question number 1. Now the diagram shows the distance time graph of Mrs. Brown. Now before we attempt this question, please take note there are two types of graph, distance time and speed time. And before we even begin, we need to take note what is this graph. It is given here as distance time graph. Okay. We can also see from here, the axis is distance in meter and time is in minutes. Okay, in this graph, we see that Mrs. Brown traveled from O to A, and then from A back to B. Now, can you find Mrs. Brown's speed? Now, the speed is actually derived from the gradient. Okay, so what we do is that we need to find the gradient of the line OA. So we draw this line here. Now the change in the y is from 0 to 1000. So this is 1000 meter. Okay? Whereas the change in the x or the time is from 0 to 12. This is not 10. 10 is here. 11, 12. So this is 12 minutes. So what is the speed from O to A, represented from O to A? So we find from part 1, the speed will be the gradient. So the gradient will be the vertical change over the horizontal change. This is 1000 over 12. Now, if you use a calculator, 1000 divided by 12, you are going to get 83 and 1/3. Now, what is the unit for the speed? This is in meter, this is in minute. So, meter every minute. This was part 1. Now, for part 2, the speed will be equals to, again, 1000, but now we are looking at this triangle. This is still 1000, but the time taken will be 30 minus 12 is going to be 18 minutes. So 1000 divided by 18, you are going to get 55. We can write down like that. This is a recurring value here, meters per minute. Now, for speed, I understand that this is a negative gradient. We don't put negative here because speed is always taken as a positive value. Now, can we find Mrs. Brown average speed then? Average speed, okay, is defined to be total distance travel over total time. Okay, over total time taken. Okay, what's the total distance travel? Total distance travel will be 1,000 meter plus 1,000 meter. So this is 2,000 meter. Total time will be 30 minutes. So the average speed will be 2,000 divided by 30. You are going to get 66 and 2/3 meter per minute. Or we can write down 66.6. Okay, up to you. These two are correct answers.